start nitric acid by Oswald's process. Last class we have seen preparation of nitric acid in laboratory method. Now we will discuss nitric acid by Oswald process, and this is the industrial method. Industrial method of preparation. Okay, so this is the industrial method of preparation of nitric acid. So this Oswald process or industrial method of preparation of nitric acid can be done in three steps. In three steps. Okay, so what is the first step? So first, okay, let me rub everything and let me start. So this one will be step 1. What is step 1? First of all, let me clarify. After that one, I will go for this explanation. So in the step 1, that one will be catalytic chamber. This one is catalytic chamber. The name itself, it is catalytic chamber. So here it implies something catalyst must be there. So what is the work of this one? So here catalytic oxidation of ammonia takes place and it convert to NO, nitric oxide. So in this step it is converted ammonia to nitric oxide. What is step 2? Step 2 is oxidation chamber. So this one is catalytic chamber, this one it is oxidation chamber. This one is oxidation chamber. So it is oxidation. So it means that whatever we are getting in the previous step, in the second step that product get oxidized. So what happens here? NO converted to NO2. This is the second step. What will be the third step? This one will be the third step. Third step, it is absorption tower. This one it is absorption tower. So absorption it is written. So what does it mean? It is the nitrogen dioxide absorb water, absorption of nitrogen dioxide. Okay, let me write. Absorption of NO2 in water and product is HNO3. So here what is that one? Here we are converting NO2 to HNO3. So these are the three steps where we will discuss all these things. So first of all, so understood now? So this one it will be catalytic oxidation. So ammonia converted to NO. Remember, we were discussing this one in ammonia chapter. Ammonia, two type of reaction there. Burning of ammonia in air and burning of ammonia in presence of catalyst. Two conditions there. One will be without catalyst and this one will be catalyst. So this is the condition when we are getting the HNO3 as the product. This is the rough diagram of manufacture of nitric acid by Oswald process. Okay, so this is the three chambers that I have explained you. This one will be catalytic oxidation chamber, this one will be this oxidation chamber, and third one will be absorption tower. So here this one will be catalytic chamber. Catalytic chamber. This one it is oxidation chamber. Oxidation chamber, and this one will be absorption tower. This one is absorption tower. So first of all, let us see, whenever we are taking okay, so first one it will be, I told in the first step ammonia it is converted to nitric acid. So here let us see, let us take this one will be ammonia, that too let us take pure ammonia, and here let us take this. So this one will be oxygen. So ammonia and oxygen mixture are taken inside this catalytic chamber. This catalytic chamber, here catalyst we have taken as platinum as the catalyst, and here this one it is initially heated, and that too heat is 700 to 800 degree temperature. This one will be heated. So first of all we have to heat it. So now when this ammonia and oxygen passes through the catalytic chamber, they produce NO, and this is at the high temperature and gas also at high temperature. So temperature have to reduce. That is why we have to take this one as the cooling pipe. Cooling pipes, or some cases also we can say this one it is condenser or heat exchanger also you can say, because it exchanges the heat. So first of all this one will be at high temperature, so temperature have to low. Here by passing through the cooling pipes, this one can be 250 degree. So from here whenever it comes, again oxidation chamber, NO, it is converted to NO2. When this NO2 comes in contact with water, this one we will explain again, this water in contact, they will be HNO3, and those can be out through the tap. Okay, so step 1, let us discuss step 1. Okay, so we are discussing about this catalytic chamber. Okay, so step 1, catalytic chamber. So what happens in this catalytic chamber? Oxidation takes place. So here ammonia, this along with oxygen, it comes, give rise to NO plus H2O, and along with that one so much amount of heat is required. And remember one thing, this one should be pure and dry ammonia. Here air you can take, air it can be taken, or oxygen it can be taken. So here it is dry and pure, dry and pure and dry ammonia and air we have to take. So when we are taking this one, this let us balance this. This one will be 5, this one will be 4, this one will be 6, along with that one heat. So here the 21.5 kilocalorie of heat energy is evolved. Okay, so ratio whatever we are taking, that ammonia to air ratio should be a ratio of ammonia to air should be 1:10. All the cases this air is used. See, first of all air is used here for the oxidation, ammonia to NO, then from here NO to NO converted to NO2, here also required. That is why and in absorption tower also, in presence of oxygen, then the nitric acid is formed. And air, 1/5 part of the air is oxygen. That is why maximum quantity of air should be taken. I hope you understand this one. And here it should be pure and dry. And what should be the temperature? Temperature should be 700 to 800 degrees Celsius. Yes, temperature should be 700 to 800 degrees Celsius. What will be the catalyst used here? Catalyst uses platinum. Platinum is the catalyst used here. Okay, catalyst, and here the reaction, it is highly exothermic reaction. Highly exothermic reaction. Okay, and the product formed is here, product form is NO. Along with that one moisture will be, water vapor will be there, but here NO along with steam, because that one will be at high temperature. See this one. Okay, then another important thing is, whenever we are converting ammonia to, let me rub this one so that something I can write, take the screenshot or pause so you try to understand. Let me proceed. So here we are getting product NO and steam is the product. Here whenever we are discussing and this oxidation of ammonia, not to here, conversion. So do you think all whatever ammonia here, here it should be platinum 800 degrees Celsius. Okay, do you think whatever ammonia is come in contact with oxygen and everything converted to NO? No. Here 92 to 95% of ammonia converted to NO. What about the rest? So here rest is remaining. Here remember, in case of this one is a catalytic oxidation, but when we are discussing something different here, we had discussed ammonia when burns in oxygen give rise to nitrogen and water. Here we are not taking any catalyst. Okay, so here 4, this one will be 3, this one will be 2, okay, 6. Remember, these are the two conditions, two type of oxidation we have taken. This is the catalytic oxidation, this is the general oxidation. So, whatever the rest amount of ammonia, they will not convert to NO, rather they will convert to N2. I hope you understand now. So, here N2, it will come to N2 and steam. Okay, so, okay, then I will proceed. So, here this one will be step 1, ammonia converted to NO. Some of the ammonia, it is converted to nitrogen. Okay, then we will go for step 2. So here we had taken before step 2 something else also we have, that is the cooling pipe. Here in cooling pipe, whatever cooling pipe we had taken, this cooling pipe temperature here it is 800 degrees Celsius we had taken. When passing through the cooling pipe, the temperature converted to 50 degrees Celsius. What is the reason why it is converted to 50 degrees Celsius? Otherwise, there will be again NO2 form, that one will be again decomposed. That is the reason only why it is taken as 50 degree it is considered. Okay, so let us go for this oxidation chamber, second chamber. So here let us go for step 2. So step 2 is oxidation chamber. So first one, whatever we had got NO. NO with oxygen, here temperature it is converted to 50 degrees Celsius. So here NO with oxygen give rise to NO2. Okay, around 50 degrees Celsius. This one will be converted here. So whenever we are getting NO2 here, we are getting, obviously what will be the color? This one will be reddish brown color. This reddish brown vapors will pass through this absorption tower. This one will be step 2. Now let's require here low temperature required, easy conversion of NO to NO2 means easy oxidation. Easy conversion means easy oxidation. Easy oxidation of NO to NO2. And here decreases or minimize, this one is important, minimize the chance of decomposition of NO2. Then third will be absorption tower. So the name itself, absorption tower, we have already discussed. So what happens here? So here this one will be step 3. Step 3. First of all, let us discuss the equation. After that, we will go for it. So this gases, reddish brown NO2 gases goes here. Water is sprinkled. So this one it is filled with quartz. Okay. So now let me write the equation. Again we will go there. So here this NO2 in presence of oxygen, because air it is continuously it is going along with the gases, with water, because water is sprinkled from there, it is absorbed. So we are getting HNO3. So 4NO, 2H2O and 4HNO3. Okay, so here we are getting HNO3 and it can be taken from outside by the tap. So now let us discuss about this absorption tower. This Absorption tower, it is a steel tower. So let me rub this one. Absorption tower. Absorption tower is made up of steel. Okay, and here filled with this absorption tower, filled with quartz. Okay, why quartz is taken? Because this this quartz acid resistant. This one is acid resistant. That is why it is taken as the quartz here. So this quartz is packed in the layers. So there will be different layers here of quartz, so that there will be easily these gases which are moving, they can move easily, and uniform diffusion will be there. That is the reason only it can be. So here this NO2 goes upwards. So this one, this presence of quartz will slow down the reaction. Here quartz is given. It is first of all acid resistance. Another one, it is makes the motion of NO2 slow. So if diffusion will be uniform, this one will be slowly, this one can move upward direction. Okay. And here when it goes slow, then water is sprinkled, then this one will be uniformly better solution of nitrogen dioxide in water can be formed. Makes this one, and here another part also we can write better solution of NO2 in water. Okay, hope you understand this one. Okay, so gases leaving oxidation chamber, this is the oxidation chamber, gases leaving oxidation chamber, NO2, they go to this absorption tower through downward direction to upward direction. This one it is made up of steel, and here this one it is filled with quartz. Water is sprinkled up upward direction from this one. Here the purpose of keeping this quartz is three reasons are there. Here this one will be acid resistance. Second one makes the motion this NO2 slow down, so that uniformly they can mix with water, so that this HNO3 can be formed. Okay. So here whatever dilute nitric acid we are getting, this dilute nitric acid, it is collected at the base of the absorption tower. Can be further concentrated, because it is not concentrated, it is the dilute form. It can be concentrated by distillation or by boiling until a constant boiling mixture is obtained. So this one it is also have the constant boiling mixture, and we have discussed that one. And this one it is changes without change in its composition. That one will be this constant boiling mixture, or it is azeotrope. So here this one it is at 121 degrees Celsius. It contains 68% of HNO3. So this much it means it forms the constant boiling mixture at 121 degrees Celsius. At that temperature it contains 68% of nitric acid. So further, if we will heat more than 128 degrees Celsius, then this whatever concentrated part of nitric acid was there, that one again will become dilute, because along with the vapor of water, this nitric acid vapors also will be out. Okay, so here if you want to further if you want more concentration of nitric acid, so further distilling with concentrated H2SO4, because H2SO4 it is a drying agent. Okay, so here further distilling with concentrated H2SO4 under reduced pressure gives fuming nitric acid, fuming HNO3, which is 98% concentrated. Which is 98% it is concentrated. Fuming. F-U-M-I-N-G. Fuming nitric acid, which is 98% concentrated. Okay, so all these are this explanation part. So as a whole, let us discuss as the like the summary only. Let us discuss this one. So we will take ammonia comes, air comes, okay. So both combining goes here. This one will be, what is that? This is the catalytic chamber. Catalytic chamber. What happens in catalytic chamber? Ammonia with oxygen in presence of platinum, 800 degrees Celsius, it is 700 to 800 degree, it is converted to NO, water along with that heat. Okay, so here 4 ammonia, 5 oxygen, 4 NO and 6 water along with heat. This is the catalytic chamber. So from catalytic chamber it goes to heat exchanger. Heat exchanger. You can write this one as heat exchanger, or you can write it to cooling pipe. So here temperature 800 degree, it is converted to 50 degrees Celsius. Okay, from here it goes to oxidation chamber. So what happens here? Here oxidation chamber. Here nothing to worry, nothing to by heart. Here what is that? From here only this name itself, it implies everything. So in oxidation chamber what happens? NO combined with oxygen at 50 degrees Celsius, it converted to NO2, reddish brown. Okay, so 2, this one will be 2. Okay, from here it goes to absorption tower. So here this one is absorption tower. What is the reaction takes place at the absorption tower? Here NO2 continuously oxygen comes, oxygen, here absorption, water is, it is absorbed in water. So what is the product? Product is HNO3. Okay, this is the flow chart of nitric acid. This one will be Oswald process. Let me tell you one trick for it to remember. So here entire nitric acid, it is from the Oswald process. We can remember in this no PT. What is that? No PT. No PT. Remember this one, no PT. So here N stands for nitric acid. Name of the process is Oswald process. What is the first product? First product is NO. Okay. What is the catalyst here? Catalyst is platinum. So here no PT. No PT. Remember this one. In NO everything will be, you can remember. Okay. So no PT. Oswald process, no PT. If I have given you no PT, let us go for HCl. Something let us find out easy way so that we can remember. So HCl, for HCl, for H, and what is the name of this process? Funnel arrangement. So HF. Here ammonia, A, this name of the process, Haber's process, and catalyst, it is I, A high. Okay, then HNO3, this one will be no PT. Then H2SO4, this one will be sulfuric acid, contact process, vanadium pentoxide, SCV. Okay, so these three remember. So HF, hydrogen fluoride, A high, no PT, and SCV. Okay, so some tricks remember.